Question 8 in exercise 6.2 was particularly tricky to visualize, and it was one of those questions that 1 minute you can see the shape as intended and then the next minute you lose it again. So to help, we have a little model of it. I'll just move the camera. So I've left the sides off the lower end of the pool just so you can see the triangle that's created along there. So we had a pool that was full length 25 meters. There was 8 meters of a shallow end, if you want, and then the pool began to slope down. We had a 3 meter high end piece, and the bit that you see covered in black tape, that's equivalent to the 0.9 meters high wall, which was the depth of the shallow end. You've also got those side panels, remember, when you're looking at working out how many tiles were required. So there was quite a difficulty in visualizing this particular one, but hopefully the 3D model helps. So to get on with the question itself, the first thing we had to do was we had no measurements for the surface area of this panel here, the one that was created by the side of the triangle from where the pool slants down. But if you look, a right angle is created. We know that the entire length is 25 meters and that up to a certain portion here that's 8 meters, so that allows us to work out this measurement here. We know this is our 3 meters minus the top, minus this section here, and then we're just looking to work out what turns out to be our hypotenuse. Okay, so just to sketch that out then in pencil, we ended up with a triangle that was of this orientation. So the entire end length here is 3 meters, but that's including the top part of the pool, which is of no interest to us because we can work out what that area is. So this was 0.9, so when we subtract that away, we get a length here of 2.1 meters. We're trying to work out what this is. This entire distance here is 25 meters, and we know from our diagram that this part here is 8 meters, leaving us with a remaining 17 meters. And we just put x in. This is the slant part, but as you can see in our triangle, it's also our hypotenuse. So our x squared is equal to 2.1 squared plus 17 squared. And, then our x is approximately equal to 17.1 meters. So then what we have to do is we have to find the surface area of, put under there, the end panel, our sloped part of our floor, the flat end of the floor, the inside walls, and the triangular panels that are created at the side. So our end wall is, this is our larger one, so let's put that in there, is 3 meters by 12.5. You can check all the measurements, most of these are marked in on the diagram in your book anyway. The floor part that's slanted or lower down in the pool, the deep end I suppose, is 12.5 across multiplied by 17.1, which is the measurement we've just calculated. Our side triangle there's 2 of those, and that's half the base times the height, because this is our base and then our height. There's 2 of those, 1 on each side. Then we have the sides that are rectangles up along the top. So there's 2 of those, and they are 25 meters times 0.9 meters. And then the top end at the shallow end of the pool is 12.5 by 0.9 meters. So that's 37.5 to 13.75. Um, 35.7, 45, 11.25, and sorry, I've just realized that I left out the floor in the shallow end. But that's just a nice handy rectangle. That's our 8 meters by 12.5, and that's 100. This is surface area, so it's all meters squared. When we total that up, we get a total of 443.2 meters squared. So that's the surface area. They tell us that the tiles we're going to be fitting have a side length of 50 centimeters, which is 0.5 meters. It's important for us to change it into meters because our pool has been measured in meters the whole time. So the surface area of our tile is going to be 0.5 times 0.5, which is 0.25 meters squared. So then we just have to work out how many of those we need to cover our pool. And when we divide it in, we get 1772.8. They want that to, you're obviously not going to have 0.8 of a tile, so we're just going to go to the nearest whole amount of tiles that you're going to use. Basically what you'd order to make sure you have enough. So rather than going your 1772, you're going to order that extra tile because you're going to need a bit of it. So that's 1773. It ties in with the fact I realise that this is 0.8, which is greater than 5, and we'd normally round up for that. But even if this was 1772.2 or 0.3, you still need that extra piece of tile, so you'd still round that up, even though the figure isn't above 5. So that's 1,773 tiles. If you've any discrepancy in the calculation, the figure that you get here, it's probably going to be due to rounding that was done back up here. But as always, there is an allowance for that, and thankfully we're rounding, so it doesn't make that much of a difference. If we then go on to part 2 of the question, we're asked to find the volume of water needed to fill the pool if the water level is 10 centimeters below the top of the pool. So in that case, you're looking at 2 sections. You're going to be looking at the easiest thing to do is to separate into 2 sections. Separate it into the triangle part that's created, and then this rectangular part, or sorry, cuboid part that sits on top. So if we do that, then we have a prism. Ooh, this isn't going to be good, but you'll get the idea. We've got a prism that has a perpendicular height of 2.1. It's got a base of 17 centimeters, and it's got a length or width, if you're talking about the pool, along here of 12.5. So its volume is going to be half your perpendicular height times your base times the length of the prism. So you end up with 223.125 centimeters cubed. And over this side, we'll just do out our cuboid. So this is the top part of the pool. So we have the shallow end here, and then if you can imagine, you would have your triangle slanted end added onto it. So its full length, we've got 25 meters. Its width is 12.5, and they wanted the water level 10 centimeters below the top of the pool. So our height of the pool originally is 0.9. We're going to subtract 10 centimeters, which is 0.1 of a meter, and we get a 0.8 meter height. Okay, so to get the volume of that, we have 25 times 12.5 times 0.8, which is 250 centimeters cubed. So we get our total volume,